Hello, and welcome to the Alliance 2022 Roadmaps on Demand. This session is the Data Lakehouses on Oracle Cloud Infrastructure, presented by Scott Howe from Oracle. Let's get started.
Hello, and welcome to session 8935. We're going to be focusing today on how you as a higher education can derive additional insight from your data by building and leveraging a data lakehouse in Oracle Cloud Infrastructure. Before we get started today, I do need to present you with what we call our safe harbor statement. If you've ever sat through an Oracle presentation, the intent really here is to remind you to make good decisions based on functionality that's available today versus something that maybe is in near-term roadmap or not available. Before we get started, I do want to share a little bit about myself, the presenter. Hi, my name is Scott Howe. I am an enterprise cloud architect focused on education and research, primarily in the Mid-Atlantic region. Prior to joining Oracle, I spent 10 years at a large university as a Banner database administrator and systems admin. And I was responsible for initially deploying Ellucian Banner back in 2006, as well as many other solutions. I helped maintain DegreeWorks and Blackboard Learn for our learning management system. I also helped to take care of Blackboard Transact for the card transactions and other core services that are common in higher education, such as maybe Adirondack for housing or Ellucian products such as IntelliCheck or Argos. But besides higher education, I've also spent some time at AWS as a specialist solutions architect. So I'm familiar with some of the other cloud service providers that are available. And I spent a few years working at a large Department of Energy contractor maintaining a Q-level clearance. So I do have some history in that vertical as well. A little bit about myself. I live in Lynchburg, Virginia. It's a small town in sort of the Southwest area with my wife, Abigail, and two children, Matthew and Keely. And we do have a little tradition. I've included some pictures from our holidays. We like to do a kind of a group contest or group costume where we sometimes dress up as Star Wars characters or maybe Guardians of the Galaxy or even Spider-Man characters. So you can see some of those pictures of myself and my children and friends joining in there. It's nice to meet all of you. Really glad that you're here today. Diving right in, today's focus is going to be primarily on how we can leverage our data and how we drive new business value from all the sources that are available to us. I mean, higher education has a ton of data. It's really about collecting that data and then figuring out how to take advantage of it. This could be things from ranging from feeds to sensors. It could be video, it could be sound and images, or more traditional sources like relational databases from enterprise applications, such as Ellucian Banner, for example, or PeopleSoft, or learning management systems, whether they reside on premises or in the cloud from SaaS providers. Higher eds need to be able to work with all types of data, regardless of where it lives, to ensure that it's available to be used together. Often performed this at massive scale and with limited resources, both budget and personnel wise. So our customers need a data platform that ensures all of this data works together seamlessly and easily. So what's the problem? What's the challenge surrounding that drives you to attend this session and have this conversation? Well, if we look at standard relational data that we're used to dealing with, it's really not all that cumbersome. We've kind of figured out the way to address that and to deal with that, whether it's relational enterprise systems or learning management systems. Oftentimes that's something that's kind of old hat to us. But as we start to introduce other newer forms of data, such as semi-structured or unstructured data, that complexity increases significantly. And this is due partially by the various types of formats, but it's also driven by the different types of velocity that are impacted by this data. Now let's take a little bit of a look at the types of data we mean by databases and app data. So this might be things like financial check-in records. I know at the university that I worked at, we paid very close attention to that time of year where students were logging in and they were doing financial check-in. We wanted to make sure that was a completely seamless process. And so that data was extremely important to report on in near real time so that if there was any issue with that process, we could react to it very quickly. Student records, we're of course always interested in determining when there's potential for a student to maybe drop out, or if they're having problems in classes. Student records are extremely critical to the success of the university. And alumni records, alumni donations drive a major funding for the university and colleges. So it's extremely critical that we have that data to access in your real time. And we've done that largely through the use of what we call data marts or data warehouses. And we'll come back to that more here as we move on throughout this presentation. But as we look at maybe some non-standard data, we could look at things like medical forms. This might include data surrounding vaccination status. That's relevant today in this day and age. A lot of times that's not going to come to us through traditional relational database means. This might be a piece of paper. I know in the state of Virginia, when I went to get mine, they literally hand wrote it on a little card. And so being able to take that in and take a photograph of it, for example, to submit that and track that, that becomes a semi-structured data form. Or maybe invoices to track whether or not a student record is paid in full before attending classes, or even still transcripts. It always surprises me how many higher education institutions are still sending transcripts via analog fax machines. And how is that record translated? And then how do we determine that transcript relates to specific classes that we currently offer at the university? All of this is relevant, and it's all in oftentimes semi-structured data forms. We go a little bit further out in the circle, we're looking at social media to gauge sentiment. This is looking at things like Facebook or Twitter or LinkedIn to see how the university is perceived. This is very critical for us. Things like phone call scripts in CRMs. If you have a call center that's reaching out to touch base with prospective students as they potentially consider attending that university or college, being able to harvest those scripts to once again, look at the sentiment of the prospective student, whether or not they're leaning toward attending or not. That's a critical data point. And then we have IoT sources, and there's a variety of them on college campuses. Everything from washers and dryers. Maybe we want to be able to display to students what washers and dryers are available on campus, which ones are full with loads and which ones are available. Or maybe we want to check to see which ones need more detergent to be filled up. Or vending machines. A lot of these vending machines these days are smart devices that can actually be used to alert us, to let us know when they need to be filled back up with additional products to be vended. All of this needs to be pulled in to a single source where we use common tools and common ways to query so that we can derive additional insight. So let's look at the way that this has evolved over time. We're going to kind of baseline some of these terms you've probably heard, but maybe it's worth kind of revisiting. First, we're going to start out with that left-hand side. And traditionally, we used these data warehouses as a way to create rich transactional capabilities. Data warehouses were created in a time when analyzing our structured data alone was enough to build really great insights. They were usually departmental in scope, or they could be enterprise-wide if you had that kind of an infrastructure, and were typically populated from other sources, such as enterprise apps. And this could have been ERP systems, it could be student information systems or learning management systems. The list goes on and on. But they were typically relational in scope, and data being pulled into these warehouses was sometimes it maintained a similar data model, but not always. More mature implementations might see denormalization practices applied to optimize analytics, or the use of star and cube schemas to represent the data differently. Along came data lakes, and the use of a data lake was really to address the need to store and manage semi and unstructured data at a very low cost. And this coincided nicely with a movement in the open source ecosystem where many projects were being created to not only store, but also process those new kinds of data at mega scale. But however, this did create some problems or issues that needed to be resolved in that customers would usually end up with largely parallel worlds. They would have their data warehouse with all their relational data, and then they would have their data lake running side by side for the semi-structured or unstructured data. And that oftentimes created silos with information and sometimes with tools. It's very difficult to come up with a common means to join both data sets together, blending the traditional data warehouse, whether it was departmental enterprise or the data lake in one query. But I say that to bring up the fact that that is really the need that lakehouses address, or data lakehouses address. It's a means of consolidating analytics platforms into a lakehouse, and it brings the best of both worlds together into a unified architecture so that the model can really help you to manage and query all types of data together. So let's take a moment and look at this. How do we modernize an existing enterprise data warehouse? How do we turn it into a lakehouse? I think first we need to look at what exists as a big picture that comprises the different components of maybe a traditional data warehouse. And then we can move into how do we take that and make that into a lakehouse architecture. First, if we look at the far left side, these are all the data sources that are coming into our traditional warehouses. These are comprised of operational databases, maybe it's external data sets, enterprise apps or SaaS apps, and data from events or sensors, such as IoT devices. It could even be data streams from social media flowing into the data warehouse. But in most scenarios, customers are trying to gather that data from many sources and act on them in a variety of ways. If we look at the center, this is the data engineering phase, the first box to the left. And this is really focusing on what solutions we have for integrating the data that allows customers to batch, stream, or transform it so that it better flows into that data warehouse. This may be more traditional applications you're familiar with. This might be something like Oracle Data Integrator or Golden Gate. And there's a myriad of other tools that are available to do both change data capture as well as ETL or ELT, where we take that data and enhance it and transform it into something that's more appropriate in a data warehouse. Now, that middle green box is the data management area. And this is where the data is stored in a departmental data warehouse or a data lake. This is where we physically store the data in a place that makes the most sense depending on the type of data that it is: relational and relational databases, unstructured and semi-structured data in other locations, such as object storage, for example. And we'll get into that more here shortly. And then that third column and that third green box is the analytics and AI. This is where customers use solutions such as Oracle Machine Learning, OCI Data Science, Oracle Analytics Cloud to develop those visual models and harness the insight from the data and present it back to the business leaders to actually make data-driven decisions off of. So the meat of today is really going to be taking a look at how Oracle Cloud Infrastructure and its data services work together to form an integrated platform for lakehouse architectures. We're going to take a look at the range of investments that Oracle has made across open source projects and our autonomous data warehouse solution to support Lakehouse. And we'll speak about examples of how higher education could utilize these architectures in a lakehouse today. So we looked at data warehouses and the foundational data building blocks to build a data warehouse. Let's now take a look at a lakehouse architecture and see how those compare. Now, there's really 6 main components that make up a data lakehouse architecture, at least in my eyes. And if we start at the top left corner there with the open source tooling, this is usually going to be comprised of the most popular open source tools for data management. And largely this is driven by breadth of choice. This allows customers to bring a random array of an assortment of different types of open source solutions. And you really are seeking compatibility there wherever this is going to run. Number 2 is that data store. This is really, the need here is to have this optimized regardless of data type. So once again, if this is unstructured or semi-structured data, that's probably going to reside in something like object storage. Number three, that data warehouse. It's no surprise that Oracle is well known for its relational database services, and our data warehouse services are no exception there. The idea here is to provide rich analytic capabilities on transactional data. Customers have a myriad of choices when running this out of Oracle Cloud Infrastructure, including our autonomous database services or our MySQL HeatWave service. Number four, that bottom left box is data movement. Now, the idea here is to provide that change data capture so that we can capture the data where it's created and move it and start to process it, as well as enhancing it with ETL and ELT processes. This transforms the data into something we can actually utilize in the format that we need. The center bottom box is all about bringing intelligence to the data that we've now collected. And this is about applying AI services to prep and predict how we might be able to utilize that data. And then the last bottom right-hand corner is all about providing a unified way to define the data that we have in our lakehouse. And this is usually through tables and metadata, a lot of times in a data catalog, so that we actually know how to derive additional insight from the data that we do have in the myriad of sources that we maintain. Let's take a look at the OCI aspects of this as it relates to higher education. If we look at all of the different sources on the far left of this screen, you might be pulling in sources from Oracle PeopleSoft Campus Solutions, for example, or maybe it's a Lucian Banner. Maybe it's Blackboard for your learning management system. Maybe that's on premises, or maybe it's in the cloud. Maybe it's SaaS applications like Canvas, or maybe an open source learning management system like Moodle. Maybe it's Blackboard Transact, where you're tracking card swipes as students move throughout the campus and check into their dorms. Maybe it's SaaS solutions like Salesforce or Workday, or CRM solutions like Dynamics 365, or a broad set of IoT, such as those washing machines or vending machines that I mentioned earlier. All of this data is going to be moving in from those data sources on the far left into that lakehouse architecture. So if we take a look at those 6 pillars again, how does Oracle address those needs? Well, it's through combination. It's a broad portfolio of services that are specifically designed to work together, built around open source tooling for data management, providing a breadth of choice. These include Apache Hadoop for the Hadoop ecosystem, Apache Spark, OpenSearch, and more in that managed open source tier. Dataflow, if you're not familiar with it, is a managed Spark implementation, and it's great for parallel data processing, ETL, and real-time data aggregation. If we move to the right in the data warehousing pillar, this is going to be featuring things like our autonomous data warehouse or MySQL HeatWave. If you're not familiar with HeatWave, it's a distributed, scalable, shared nothing, in-memory hybrid columnar query processing engine designed for extreme performance. If we continue on around that circle, we can look at the data stores in the middle there. This is all about being able to store the data in the form in which it was created, and that's all about object storage for that semi-structured or unstructured data, or even relational data. If we go over to the right, we can look at the data definition and discovery. This is really primarily the data catalog service that's all around actually creating metadata and how that data fits into your broader data catalog. Moving right around, this is the AI services. Once again, this is all about ways that we can bring intelligence to the data that we have discovered and make sense from it. And this is brought about a couple of different ways. One, we have AI solutions or pre-built AI services to make sense of that unstructured data. An example of this would be utilizing something like our geospatial with AI services to find and filter outliers. Or it could be services such as Autonomous Data Warehouse that have AI for identifying trends built right in. And then that last piece is that data movement that I mentioned in the previous slide. This is all about doing that change data capture and enhancing and transforming that data. And this is largely made up of services that can be self-managed by the customer, or we offer managed services that run out of Oracle Cloud Infrastructure to reduce the administrative overhead. This is Oracle Data Integration or Oracle Cloud Infrastructure Golden Gate, which run natively out of our cloud. All of these components really are designed to feed that data into a variety of targets, whether it be any business intelligence tool, machine learning and data science applications, or even standard OLTP applications. And on your campus, you might be familiar with using products like eVision's Argos or Microsoft SSRS, Oracle BI Publisher, Oracle Analytics Cloud, or even Tableau. All of these are compatible and can be used for BI and analytics for the Lakehouse architecture running in OCI. So I hear you. I hear you saying, you've convinced me. I want to get started. What's the best path? Our customers can easily start where they are today, and often without rewriting any new code at all. Let's talk about the three main paths that many customers can take when deciding to build a lakehouse on OCI. The first is going to be building a new data lake or moving existing data lakes to OCI. And this would often be where customers already have a data warehouse. Maybe they already have that data lake, or maybe they're embarking on the journey to create that data lake to keep all of that semi-structured or unstructured data. And we'll talk about that in more detail here soon. The second path is going to be largely taking your existing data warehouse and modernizing it into a data lakehouse. And then that third path is going to be developing a solution centered around SaaS applications. Maybe you are a customer that's looking at leveraging our Oracle Fusion SaaS applications, and you'd like to continue to be able to derive insight from that data that resides in those SaaS apps. And we have solutions centered around being able to connect SaaS applications into a lakehouse architecture so that you can join it and use the data that exists in your data warehouse as well. Within each path, I'll highlight the investments we've made to accelerate your own lakehouse transformation. So the first path for customers is largely centered around moving or building a data lake in OCI. Now, many customers have existing data lakes, but they tend to be kind of expensive to manage on premises or even in the cloud. And what I mean by that is not necessarily expensive from a licensing perspective, but it's expensive from a labor perspective. I often say running a data lake self-managed is kind of like, it's free like a puppy and not like a beer. And that metaphor basically means that if somebody came along and offered you a free beer, there's not a lot to consider. There's not much of an impact. You go ahead and drink that beer and enjoy it, and there's not much of a repercussion. But if somebody came along and offered me a free puppy, I still have to consider what the implications are with that free puppy. I am now responsible for a life. I have to provide vaccinations and medication and walk that dog and feed that dog and care and love that dog for the foreseeable future. And likewise, data lakes can be much the same. It may be that you're basing this around a lot of open source tooling, which happens to be free, but the investment from an infrastructure perspective and from a labor perspective can be substantial. So the way Oracle is addressing this is by making it easier to move those data lakes to OCI, and that dramatically reduces the full total cost of ownership, including reducing egress charges, for example. OCI offers the first 10 terabytes of egress traffic out of the region every month for free. This is a value add that we provide for all customers running workloads out of OCI. And above that, let's say you sent more than 10 terabytes out of the region a month. We actually offer a flat egress rate above that, making it very simple to calculate your egress charges. Now, this is a significant differentiator for Oracle when you compare to other cloud providers, largely because many cloud providers offer only about 100 gigs in their free tier before they start charging. Now, this can equate to thousands of dollars of saving, especially in lakehouse architectures where you're likely to be moving data around frequently. Above and beyond that, you could look at using something like our Fast Connect. Fast Connect provides dedicated bandwidth and consistent low latency directly from a co-location to Oracle Cloud's regions or between your data center and an Oracle Cloud Infrastructure region. When you use Fast Connect, there's no additional charge for any egress traffic above and beyond the Fast Connect cost. And I believe we're one of the only cloud providers that's doing that today. So we're making it very easy to move data at scale. And we're doing this with new partnerships such as WANDisco. If you're not familiar with WANDisco, it's all about providing a high-speed interconnect between cloud providers. So the value that WANDisco provides is maybe I want to have a data lake in OCI, maybe I want to have pieces of a data lake in AWS or pieces in Azure. I can now use WANDisco to interconnect multiple data lakes and derive insight from all of those. Now, OCI also includes capabilities to make it easier to migrate or build your data lake using existing open source skills and tools. So you don't have to relearn your resources. These are built off of common open source products such as Oracle Hadoop, Oozie, Hue, Zookeeper, Kafka. You're familiar with many of these if you've looked at the big data and open source stacks. First, we recently announced a major update to our Hadoop-based big data service, or BDS for short. BDS now runs our own Hadoop distribution optimized for OCI, and this creates a greater performance than we've ever seen before. I also want to draw your attention to new capabilities on our Dataflow service, which is a serverless Spark managed offering, which makes executing batch workloads much easier. Excuse me. Dataflow features a new serverless interactive Spark SQL, including OLAP indexes for much quicker querying. This enables rich interactive analytics over your data lake, with none of the complexities that come with managing clusters. Paired with our autonomous data warehouse or MySQL HeatWave, it gives you everything you need to prepare and analyze all data. Now, the second path for most customers is modernizing that existing data warehouse. Every data warehouse can easily become a lakehouse, so you can analyze all data seamlessly. Even better, this ability is entirely transparent to your applications. For years, Oracle's Autonomous Data Warehouse, or ADW for short, has enabled customers to write SQL joins across their data warehouse and data lakes natively. But we've recently made some enhancements to this to increase its velocity, make it faster and easier to scale. ADW now utilizes a new query offload technology that provides more CPUs and network channels when accessing OCI object storage, where much of that unstructured or semi-structured data is going to reside, and join it against relational data with a single SQL query. This enables organizations to analyze all of their data from the data warehouse to the data lake with faster queries. To make it even easier to write great SQL over your data lake, we've integrated ADW with the OCI data catalog so you can discover, realize insights, and query against all tables within your lakehouse easily, regardless of which service it runs on. Since I mentioned the OCI data catalog, I do want to spend a moment there and just dive a little bit deeper into what this offers. The OCI data catalog is all about providing a metadata management service. It's ideally suited for doing data discovery and supports data governance. It's really oriented towards providing a single source of truth, including an inventory of all of your assets, regardless of where they reside, a business glossary so that you can find the data you're looking for, maybe even if you're not familiar with the different data sources, and a common metadata store. It even supports on-premises, OCI, and a collection of key non-Oracle data sources alike. Better still, OCI data catalog is available at no extra cost for OCI members. A final path that I want to discuss today is really centered around customers that are looking to use a lakehouse to get more out of your application data. Oftentimes, our customers have the data and data models within their business applications. And for higher educations, frequently that's in student information systems, for example. As more customers migrate components of their business applications to SaaS models, whether it's human capital management or a learning management system that's running on SaaS. This can create some challenges when it comes to correlating the data that resides in those SaaS with the traditional data models, or data warehouses, I should say. The Lakehouse is all about making it easier to join that application data with important real-world data that impacts your business. So an example of this would be using your Lakehouse to join financial data from your Oracle SaaS implementation with grades from students in a student information system. Maybe that's running on premises or an OCI, and you're looking for trends and relationships impacting student success. OCI Lakehouse architecture supports any application, including third-party apps, homegrown applications, and of course, Oracle Fusion Cloud apps. And the way that we do that is through a new recent interaction between SaaS and OCI. We've recently introduced an enhanced tool to make it easier to build data lakes in OCI, starting with your SaaS application data and data models. You can do this with the new OCI data integration service Fusion connector to easily extract your SaaS data into your data lakehouse, or use OCI Golden Gate to keep your applications and lakehouse data in sync in near real time. In the same workflow, our AI services can then be used to enrich the data with pre-built or custom trained models so that you can do better prediction, do better analysis, and derive additional insights from that data in both sources. If you take anything away from today's presentation, I really hope that you take this away. You probably wouldn't take much of a note if you were driving down along a road and you happen to see a field full of cows. That's not really much of a sight. But if you're driving along and you saw a purple cow, you might stop and say, hey, look, that's a purple cow. And much the same way, Oracle isn't the only cloud service provider that offers services that enable this data lake architecture style. However, Oracle is the most mature in many of these categories. They've been providing relational database services since the 70s. Independent analysts like Gartner and Forrester consistently rate these products such as Golden Gate and Data Integrator at the top of these quadrants in their space. And we're well known for our artificial intelligence and machine learning in these sectors as well. So if nothing else, I hope that I've been able to show how Oracle is differentiating, and we provide very rich, mature services to help you build a lakehouse architecture. But above and beyond that, I'd like you to take away 3 things pertaining to Lakehouse on OCI. The first is that you can analyze any database, any application from anywhere if your Lakehouse is running an OCI. Secondly, you can store, understand, and analyze all of your data using consistent tools. And number 3 is you can accelerate your solutions, whether you're starting from scratch or an existing data warehouse, or if you have an existing data lake. For more information, we would prefer that you would, for more information, we'd like you to take a look at oracle.com/lakehouse. This is our Getting Started on Data Lakehouses with OCI resource page. And we would really appreciate your insight on the session. If you wouldn't mind rating us and giving us some feedback so we can incorporate that into future sessions, we would greatly appreciate that. And we appreciate you attending today. Thank you and enjoy the conference.